Peace be even you. Hello everybody. Inshallah, we will do webinars which will consist from more than 5 sessions about seismic interpretation and 3D static model. Our seismic data which we will work on it are acquired from Egypt in field called Amman field. This field are belong to Agiba company which are found in Egypt. Seismic data are consist from almost 10 lines from seismic 2D, 5 L line and 5 X line. You can download this data through this link which I will put it in the description of this video. You can download it from Google Driver. Sorry. You can copy this link and go to Google Drive. You can put it in the description. Sorry, you tap. Yeah, you can download this data from here. After you can download this data, it will download it as a compressed file. It says a folder. This is called as Agiba data. After you extract it, this data are consist from 4 wells: Amman 4, Amman 35, Amman 39, and Amman 41, and seismic Amman formation tops, and VSP and wellhead into format PRN and Excel sheet. Firstly, we will go to petrel and open petrel software, which are belong to Schlumberger company. After I opened the petrel software, I will go to the file and choose a new project. After I open the petrel software and make new project in the petrel, firstly I will input the well data in the input, or input the well data in the software. Firstly, you can go to the new well folder, and there are more than 2 ways to input the wells data in the petrel. First way, right click in the well folder and choose the well manager. You can choose from this message the coordinate system which are wells are located in it, or you can continue especially unaware. In well manager you can input number of wells which you have. We have almost 4 wells, so we will input 1, 2, 3, 4. We will write in this field the name of each well and unique well identifier. You can ignore this fields and input X coordinate and Y coordinate and so on for or this table. We will go to the data. desktop أجيب الداتا أمان 4 أمان 4 you can choose a coordinate system and from this file last file. Yeah, x coordinate of wellhead. Copy it. Firstly, Aman 4 x coordinate, y coordinate, Control C and Control V. And well symbol says well are well oil well, and so on. You will input the well data value, or calibration value. You can get it from this file. Yeah, Aman 4 status oil X and Y and KP and TD. But another wells as Aman 31 and Aman 41 aren't found in this file, so we will close this file and continue to enter this data. And other wells such as Aman 35 and Aman 39 and Aman 41, this x coordinate and y coordinate TD and QP aren't found in their list, so that we can take this information from mod logging file of this well, such as open this file. Yeah, x coordinate and y coordinate and RKB. X coordinate copy this value this will name our Aman 35 so that we will name it Aman 35 x coordinate, place this space and x y coordinate KP will dot name RKB RKP MSL, copy it and paste it in this field, and so on. TD, or total depth, copy it and up to 10, and amount 39, now I entered the 4 wells in the well manager. I select these wells and click apply. Okay. If you go to the well folder, open this, you will see aman 4, aman 35, aman 39, and aman 41. This well are defined by the symbol of oil, but the other aren't defined. So we will go to also to the well manager, and define the status of the other wells. Oils. I know the status of the wells from the data. If you research it in the data, you will know the well status are oil. Apply. Okay. So 4 wells become are oil. If you go to this window and choose map view, the wells become active. The wells become located in the specific location of it. This window called map window. You can display the wells in 2D window also. Yeah. Yeah, and you can select the axis. Yeah, wells become displayed in the 2D window, and also you can display it in 3D window. Now we will go to enter or input the well logs data for each well. For example, right click in aman 4 and select import on selection. The type of coordinate of the wells are maybe well log ASCII, DLIS, or LAS. We will choose well log LAS and go to the aman 4. Yeah, choose some, open. This window are found when you input the wells through LAS coordinate. This window consists from matched logs and unmatched logs. There is no any logs found in unmatched log. That means all logs are matched in this well. So that we will click OK for all. Open it. Well logs. Yeah. The logs become entered in the well logs of the aman 4. This is the logs of curved logs of aman 4. aman 35, right click, import on selection, open. Series and BIF log are unmatched to the other logs. So the petrel software automatically will match it to the another logs. Click OK. Yeah, these logs. Now I input the other logs. And each will have any specific logs. So now we will go to the window and choose a well section window. Create new section window. That's the name of X section window called X section 1. Okay. The wells become active. You can run it. It will have an index, only one index track, subsea TVD. So we can go to the template settings, and insert index track. Now you have 3 index track. The first we will call it measure depths, and second specified it TVD, and third specified it subsea TVD. Click apply. Okay. Yeah, it will have 3 index tracks. The first MD, and second TVD, and third subsea TVD. Now we will also go to the template settings to run the tracks of logs. From here, add new object. We will select track. The first track in the wells, we will input in it the log of gamma ray log. From here you can research about gamma ray. Click on G button in your keyboard. Yeah, gamma ray. The limits of gamma ray from 0 to 150. Minimum value 0, maximum value 150. Style of gamma ray, we will select it the color of gamma ray and choose a red color. Okay, and click apply. Now the first track in it will become gamma ray, and it will have it is specified gamma ray log, such as in AMAN 4, AMAN 35, and AMAN 39, and also AMAN 41. We can insert another track. Insert another track, and we will input a new log. The second track, we will input the resistivity log in it. Resistivity log. Click R button in your keyboard. Yeah, resistivity. You can choose any type from the resistivity logs and insert it in your wells. Specifically, or required to be, this log must be found in your curves of logging. For example, we will choose deep resistivity and the limits of it. The limits of resistivity in our specified area start from, or the minimum value in it, 0.2. The maximum value are 2000. The style of resistivity, we will select it as aqua or blue color. If you have in your wells shallow resistivity and medium resistivity, you can insert it also in this track or another track. Okay. Other logs such as the neutron caliber, density, PIF, SP, you can also insert it in new tracks or in one track as you like. But now we will move to enter or input the formation tops in each well and make correlation between the formation tops of all the 4 wells. Okay, go to stratigraphy toolbar and choose new well tops folder. New well tops folder and edit well tops. Okay, put this tool here and let us open it. Right click in stratigraphy, and choose insert zone. You can open it. Yeah, become there are an horizon in the stratigraphy or formation tops. Now we will move to the data to open the file of formation tops. To know what are tops are found in our wells. Let's scroll. أجيب الداتا. Yeah, formation tops. This is affirmation tops of wells, but these wells aren't found with us. Okay, so we will close that and choose this file, Aman formation tops. Yeah, it is our wells, Aman 4, Aman 35, and Aman 39 and Aman 41. These formations which are found or appeared in this well and so on in the other wells. Okay. For example, we will choose this formation, Mogra, and called first horizon. Mogra. Apply. Okay. The first horizon with us become called Mogra. This horizon appear in 575. Okay. Copy it. Firstly, activate to appear in this field, and you can put it in anywhere in the wells, and right click in the horizon and put the specific tips of it as we copied it. Okay. Now this horizon become in the right position in the stratigraphic column, and so on for another wheels. You will input all formation topes in this wheel, and so on in it, and so on in it. We will choose the tips in more in depth in the other wheel 35 wheel, amend 35, and go to amend 35 and put it. Make sure the horizon are active in this field, and right click. Okay. Automatically spatial software puts the formation in the right position in the stratigraphic column as we put steps in it, and so on in the amend 39. Copy it and put it in. Make sure the formation are active in this field. Okay. The last wheel. Okay. Now we entered the first formation tops, which are called the Mogra formation in each wheel, and made correlation between the wheels based on the position of Mogra formation. Okay, we will input another tops such as the Hohmann formation. Right click in stratigraphy and insert zone or horizon. This zone or horizon we will call it go to settings of the horizon and call it Hohmann. Sorry. Hohmann formation. Apply OK. Okay. Put it in any position in the wheels and right click in it and put the location in which we copied it. Click OK. Okay. And now we come also enter the home information in each each wheel, and make correlation between the horizon in the four wheels. Okay. And so on. You can input the other formation tops which are found in the Excel sheet file. Other tops you can input it and make correlation between them in each wheel. Okay. Now we will go to the petrel software and close it, and we will input a check shot file or VSP. Each wheel must have a specific VSP file or a check shot file. And in our data we have only one checkshot file or VSP file. Open it. In this file there are measure depths column and two time column. This file VSP make seismic to well tie between seismic and well through this file checkshot or VSP. Checkshot or VSP. So we will try to input this file in a man 4. In a man 4, go to a man 4, right click, import on selection, and choose VSP. But before you select the file, you will choose a file of types. This type of checkshot or VSP are called a checkshot format ASCII. A checkshot format ASCII. Go to Agiba field or data and choose VSP. Open. The column which are found in our file only two column, but here there are 3 column, so that we will delete one first TVD, okay, and become the columns become 2. First measure depths and second two-way time, okay, and active connect to trace and choose a man 4. Then you can click on OK. The name of it are VSP.txt. Type check shot. Okay. Click on OK for all. Okay. And we will now you can go to the settings of a man 4. Settings. You can close it and go to the time. Yeah, and active VSP and put it first and run it. Apply. Okay. Now we input our wells data and other files which are belonging to the wells, and now we can input the seismic data, so that we can go to the home and go to folder and choose new seismic main folder. Yeah, after we choosing it, you can choose new seismic survey. Now your seismic main folder have an survey one. Click on right click on it and choose import on selection. Before you choose seismic, you can select type of the data. We will choose SegY seismic data. Okay, and choose lines. Select lines. First and second file aren't lines of seismic data, and click open. Yeah. Name of seismic first line are called 5420, and type 2D seismic data. Template of our seismic are seismic default, but if we will work in seismic inversion, or if we will choose other templates of seismic, but now we will choose seismic default. Domain of our data are elevation, time, and okay for all. Yeah, now you can go to the survey. All lines are completed the loading in the survey file. So you can appear or display this seismic data. Uh, for example, go to window and choose the map window. Select survey. Also, you can display the wells as you see. Now you show the wells are located on the seismic lines. Also, you can display it in 3D window. 3D window. And choose an L line or X line, as you say, and you can select for the survey. Also, you can active the wheels. As you see, the 4 wheels and seismic survey are located in a specific location. You can active only wheels, for example, and only line. Yeah, or choose line are close to the wheels. For example, this. Yeah, now you are so the wheels are located on seismic section. You can also run other lines. Now all A lines and X lines are displayed in 3D window. You can visualization the seismic and logging data as it is. And you can solve the relation between the A line and X line and more relative closely between it, such as this reflector. It may be this, but there are cutting in it because it means there are fault in this area, for example. Okay. Now also you can open interpretation window. Interpretation window. And select any line such as this line. As you see. And select amman4. Yeah, now you are see amman4 are located in seismic section. Also, you can run the formation tops in this well as this. Now after you located seismic the well amman4 the well such as amman4 in a seismic section, you can run the well tops of each well and choose it and go to the settings of well tops, attribute. Yeah, open attributes and close Z and two-way time, and you should active the service to appear the name of it. Now we input the well logged data and other related data such as photos, formation types, and the checkshot format, and seismic data in the petrel software. In the next video, we will learn how to picking the seismic horizon in petrel software. I am pleased to discuss this section for you, and see you later. Goodbye.